We're going to use our guru to determine the least squared regressions line for the example we're working about high temperature of the day and hot coffee sales. So if you want to do this along with me, you're going to need to go to My Groups. And you should be a member of our 153 online group at this point. So you can show My Groups. Click on Math 153, then on the online repository, and you'll see a bunch of data there. If you scroll down a little bit, you'll see a data set called high temperature and coffee sales. That will be the data set we're working with. So click on it and then import that data set, and it will be in your data panel. I've already imported it, so I'm not going to demonstrate importing it, but you can do that if you want to pause this video and get the data and then join back in. Okay, now that we have the data, we're going to go to Analytics. We have a drop-down menu. We're going to go to Linear Regression, Simple Linear. We're going to select that hot coffee or high temperature today and coffee sales. And mind you, it's probably at the bottom of your list since you just imported it, and you probably won't have as many data sets as me. But grab that, select that. Once we select it, it knows, if you can see, if I click on either response, it has the two variables. So let's do our predictor variable. That's our explanatory variable, as Hawks calls it. And that's going to be our high temp. Our response variable here are the coffee sales. Now, that's pretty much all I need to do to get the least squared regression line here. Actually, you'll get a ton of output by just picking the roles for your variable, which one's on the x-axis, which one's on the y-axis. If I click on the preview button, we can see, we didn't talk about this in our last one, but it's a high negative or a strong negative correlation here at negative 0.937. Also, here is the model I kept talking about in the prior video. I just rounded it to 2 decimal places. Because we were working with money, it made sense to round it to 2 decimal places. And so that's how you get the equation. That's how the line of best fit. That process I described to you in the last video can be done in literally a split second with software. And there it is, the line again with the data points. And so you get your correlation R here. You can get the regression or equation of the least squares line, or the regression equation here. So it's a really neat place to get that information. Before we close this video out, I'd like to talk about interpreting slope. It's another thing Hawks likes to ask you to do, and most teachers want to ask you about. So we want to interpret the slope. So the question here is, which of these numbers in my model here, up here, my regression equation, is the slope? Well, it's the one that's multiplying onto our explanatory variable. That's our slope. So if you think about slope from a prior course, a lot of students will remember this idea of rise over run. And that's a great way to remember it because it's a very visual, spoken word way of what's happening. And so when we try to figure out, and take our negative 32.17, it doesn't quite fit into that format of rise over run because we got a decimal out of the software. Well, I'm going to do something a little unorthodox, which is force this number of negative 32.17 into a fraction by simply placing it over 1. So it is in fraction form now. So we can talk about the rise and the run. So we have a negative number up top. So we're going to not rise, we're going to go down as we saw in the model. We're going to fall instead of rise, and then we're going to run 1. So if you're thinking about that, if you're really visual with graphing, you're going to go down $32.17 or boxes and over 1. So what I'd like to do is to remind ourselves what our variables were. Our response variable is the y-axis, so that's the sales, and our explanatory variable is the x-axis, what corresponds to run, which is degrees Fahrenheit. So what I'm going to do here is kind of show you how I form a sentence, and I've shown students how to do this over the years. So I'm going to draw a little bit here. I'm going to start over on the upper right, and I'm going to cross over the word sales and the numerator of our slope, which translates to the hot coffee sales will decrease. I'm saying decrease because we have a negative slope. And how much are they going to decrease? $32.17. That is the value in our numerator. So again, we said we're going to fall $32.17. Now, I'm going to now pick up the one underneath and wrap it around with temperature. So this is the second half of my sentence, which will read 1 temperature, 1 degree Fahrenheit, if you read from left to right, for each additional degree warmer outside. So again, I start at the top. I announce the hot coffee sales is my variable. I say it will decrease because it's negative. I then use the actual numerical value of the slope, $32.17, for each additional degree warmer outside. So by placing it over 1 is quite useful because it's going to be per unit of my explanatory variable. And since my explanatory variable is temperature, for each degree warmer. So I hope that's helpful in interpreting slopes, which you'll be asked to do. And finally, just to close this out, I want to talk one more time about predictions. Now, we were predicting in our prior video a lot for values we'd already observed in our data, and that was to help us to create and compute the error that was present. But we can also make predictions for values that we didn't necessarily observe in our data set. So if you looked over the data, again, you'd notice that there was not a day of 55 degrees Fahrenheit for the high temperature. So if I still could use our model, it's another use of the model would be it's predictive. It can predict the potential value for your sales on a day where the high temperature was 55. So I'm going to take the model again that fits our data the best. I'm going to plug in 55 for temperature. If I multiply those two numbers together, following the order of operations, I'll get 1769.35. Finish out with a subtraction, and our predicted sales for that day is $1,790.59. So we can interpret the slope. We can use the model for predictive power, and it gives us just a little more insight in how the high temperatures of the day affected our hot coffee sales at the cafe. Thanks for listening.